Okay, higher level 2014, paper 2, question 8. Now this is to do a Poisson distribution, but we can't, for what we're about to do, use the inbuilt Poisson PDF command. The syntax won't allow it. So I'm going to have to define my own one. I'm going to call it px, m, where m is mu in a parameter of the Poisson distribution. I'm going to press Control equals, and to define this to be the formula for the Poisson distribution as we know it. So that will be e to the power of a negative mu multiplied by mu to the power of x, all divided by x factorial. To get factorial, it's the symbol button to the far right of the letter G on the keypad, and then you get the factorial button. So I've just defined my function to be the one I'm interested in. Now, we are told that the Poisson probability when x is 2 plus the probability when x is 3 should equal the probability when x is 5. Now when I press enter, it will give me an error because it doesn't know what m is, but I can now go to menu, algebra, numerical solve, paste that in, and try and solve it for m. Now it tells me the value of 0 is one possible solution for this. There may be other ones, so just by pressing up and enter, I paste that line in, press Control equals, and I'm going to set m to be something greater than, not equal to, Control equals for greater than 0, and it pulls back another value, 5.55. So that's the value we're going to use for the second part of the question, and I want to keep that exact without any rounding errors. So I'm just going to do m to be defined as being equal to that value there, and I have it stored for later on. Now, the Poisson distribution, the mean and the standard deviation, the mean and the variance, are exactly the same. So we're now being asked to work out the Poisson distribution probability between 3.19, it's going to be that value minus the square root of that value. So one standard deviation below the mean, so that number there, to one standard deviation above the mean, to that value there. But obviously the Poisson distribution is discrete, and so we're looking for values which are greater than 3.19, so that'll be a 4, and less than or equal to 7.9, so that'll be a 7. So now we can go to the Poisson distribution. So I'll do menu, I can go probability, distributions, Poisson CDF. For the parameter of mu, I can just use m as it's there. The lower bound is 4, as we've just discussed. The upper bound is 7, and we get the value of 0.607 without any rounding errors. We're done.